So I want to save this one final question. This is an optics question that was released from the diploma exam a few years ago. And if this was on the diploma exam, I'd feel a lot of pity for my students just because it's a really hard question. This is aimed at like the top of the top students. It's really hard and it's really going at critical thinking. Like, it's not an easy question. So we want to look at this and we're going to dissect it. Let's see what we have going on here. So we got students, they're going to use 3 of the optical apparatus that are illustrated below, and they would like to produce a focused real image in a darkened room. One of the apparatus has a focal length of 10 centimeters. So the students place one apparatus at each labeled location on an optics bench as shown below. The optics bench is scaled in millimeters and labeled in centimeters. So the apparatus placed at location X, Y, and Z. So what we want to do is we want to place 3 of these objects at X, Y, and Z in order to actually produce a focused real image. So the first thing we need is we need a light source. Now, in terms of the light source, we have a laser and we have a candle. The light source doesn't matter. Regardless of if it's a fancy laser or it's a light source, either source of light will work. So both of these are acceptable. So we don't discriminate against the light sources, because a laser will produce an image, a candle light will produce an image. Now, in order to actually get that image, it's a focused real image. We said in order to see those focused real images, we want to be able to project them on a screen. So in order to actually see this image, we're going to need a screen in order to project that on. So we need a screen. Now, for this to occur, if we want to actually focus this image on this screen, what we're going to need is we're going to need our object. Well, actually, we'll get to that a little bit later. So let's talk about that in a bit. I'm getting ahead of myself. Now, for a focused real image, there's some things that we're going to have to eliminate. Now, diffraction gratings and double slit apparatus, we haven't actually talked about those yet, but so this would be something more, like, this is on a diploma, so you would have studied the whole course at this point, but diffraction and double slit apparatus, they're not going to produce focus images, like they're almost the opposite of that, so these are not going to work for us. So let's just pretend we didn't have these options to begin with. Now, for real images, we know a few things. We know that a diverging lens can never produce a real image. It's always going to produce a virtual image. Same thing with a convex mirror. Convex mirror always produces a virtual image. A plane mirror also always produces a virtual image. So this is what we have left for choice. To produce this image, we can either use a converging lens or we can use a concave mirror. Now, this is where it really tests the higher order thinking. Like, getting rid of the bad options is one thing, but now we have to see, can we use the mirror? Can we use the lens? Can we use the mirror? Do we have to pick one of them? Can we use both of them? Now, the key for this is it's going to depend on the optical, we're going to have to look at the focal length here. So first of all, if we pick the mirror or the lens, we know that the focal length is going to be 10 centimeters. Now, you also want to note that the distance between X and Y and Z is greater than the focal length. So that's really important. Now, what's likely going to happen is we're likely going to place the laser or the light source. We're going to place the light source at X, and we're likely going to place, if we have a lens, we're likely going to place it at location Y, which means we're going to place the screen at Z. If we're using a mirror, we're going to place the light source at X, the mirror at Z, and then then Y is just going to be where we're going to have the screen. So like the light will kind of come, bounce off the mirror, and hit the screen. So let's look at the case of the lens. So for the lens, we're going to kind of do what we'll call a proof of concept. So here's my lens. Now, this is going to be very, very rough. Now, for this, I'm going to draw my lens something like this. So here's my converging lens. Now, I'm told that my focal point is 10 centimeters, so I'm going to say I have a focal point there and there. And then our object and our image, they are located slightly beyond the focal point. So my object, in this case, the light source, it's going to be a little bit past the focal point, so it's probably like located somewhere around here. Now, I can draw a ray diagram for this. So if I draw the ray diagram, and again, this is really crude, so it's not going to be great, but it's just meant to get a point across. And then if I draw my second ray here, it's going to be something that looks a bit like, something that looks a little bit like this. Now, we are going to have this light ray focus way back here. Now, it's really hard to see, and this would be much better almost suited mathematically, but what you're going to find is that that image, or this, because keep in mind, where these light rays formed, this is our focused image. What you're going to notice is that focused image, it's going to occur well outside the focal point. In fact, it's going to be beyond twice the focal point. What you're going to notice, though, is if we place a light source at X, we place this converging lens at Y, well, the screen is not real. It's not twice the focal length away from the lens. It's only about 1.5, roughly. So what's happening is our screen is here, but the focused image is going to be focused more over here. So on the screen, you're not going to see a focused image. You're actually going to see a really blurry image. So we can't actually use this. The lens, the problem with the lens is it will produce a focused real image, but it's not going to produce it at the location we have the screen. So we're actually not going to use the lens. The mirror, let's check though. We'd better be sure that this works. So for the mirror, we're going to place the mirror at location Z. So we're going to have our light source here, the mirror here, and then the screen in the center. So again, I'm going to draw my principal axis here. So for this, I want my mirror, we'll say at this location. Again, so my screen's going to be about, oh boy, let's see what we're doing here. So I want my focal point to be, let's say here, because I want it to be 10 centimeters away from the mirror. The location of my screen's probably going to be about there. And then my light source is going to be quite far away. So it's actually going to be located at, what is that distance actually? It's located 1, 2. So it's actually located 3 focal distances away. So let's see. We got 1, 2. I'll say the images, or the object's about here. Why not? So what we want to do is we want to draw a ray diagram for this. Well, I can draw my first ray. So I can draw it parallel with my principal, well, we'll try to draw that parallel with the principal axis. Go through the focal point. And then what we can do is we could also attempt to draw a ray, this time through the focal point, and then have it reflect back through the center of curvature. So what we're going to see here, and hopefully it becomes apparent, you're going to see that my image forms at this point, and where it forms is roughly the location of my screen. So if the image is going to form roughly at the location of my screen, then we could say that we're going to get a focused image. And then we know it's real because it's the real reflected rays that are converging at this point. So we are absolutely going to use this mirror. So at X, we're going to place the source. Location Z, we're going to place the mirror. And then Y, we're going to place the screen. Now, you might say, well, hang on a minute. Could I just reverse it and say the light source goes here, the mirror goes here, and the screen still goes in the center? The answer to that is yes. So for this, there are multiple answers. The only thing that's going to stay the same is the screen is always going to be in the middle here. So at location Y, we are going to have this 9. That will always be there. Now, if we decide to place our light sources at this position X, so if we place either a 0 or a 1, what we're going to do is we're going to place our mirror at position Z. So we could say 4 and 4 with this 9. Or what we could do is we could reverse these. So instead of having the light source at X, we could have the mirror at X. We're still going to have the screen at Y, and then we could have our light source at Z instead. So for this, there's actually 4 answers. So it's a numerical response question, but there's 4 answers to it. So you could put in 094, you could put in 194, you could put 490, or you could put 491. But like I said, this is a really hard question because it's testing, do you know where that image is going to form relative to where the position of the object is? And yeah, it's a really hard question. But if you can nail this one down, you have your optics theory down to a science.